Hi guys, and welcome to Outcome 2. In Outcome 2, we are going to switch gears and start looking at bivariate data, which means we're going to look at two variables graphed together. The most common way to display two quantitative variables graphed together is a scatter plot. A scatter plot is something that looks like this, where you have your one quantitative variable, let me say quantitative variable number 1, and then we'll have another one, so quantitative variable number 2. And we're graphing kind of how they are related using just some dots. So looking at scatter plots may be the most common and effective display for data. What's nice about scatter plots is we can see patterns, trends, relationships, or maybe even the occasional outlier sitting apart from these other values. Scatter plots are the best way to start observing the relationship and the ideal way to picture associations between two quantitative variables. Big idea here is they have to be quantitative variables, so they have to be those number values. When we are describing scatter plots, we have a new acronym. We're going to use DFSU. Now, when we had graphs of one quantitative variable, we used SOX. Now that we have two variables, we have DFSU. My fun way of remembering DFSU would be don't fudge stuff up. Don't fudge stuff up. Have to remember DFSU when we're talking about scatter plots. The D in DFSU stands for direction. So this is the first thing that we need to talk about. If you have a pattern that runs from the upper left to the lower right, this is said to have a negative direction. A quick sketch of a negative scatter plot would be something like this here, where things are moving downwards. As you look left to right, they're moving negative. If we have a trend going the other way, it has a positive direction. So again, I'm now moving upwards with my dots. After you talk about direction, we need to talk about form. Form is looking at whether things are linear or whether they are curved. If there is a linear relationship, it will appear as a cloud or a swarm of points stretched out in a generally consistent straight line. So both of these that I drew up here would be examples of linear scatter plots. Generally, they're moving in a straight line. Now, it doesn't have to be perfectly linear. It could kind of deviate a little bit. This one still, though, generally follows in that straight line. If the relationship isn't straight, but it's slightly curved, okay, it might still be increasing or decreasing steadily. We can actually find ways to make this straight. We'll talk about that kind of later on in our unit. But instead of working straight there, it might have kind of a slight curve. So you might have a scatter plot like this that's slightly curved. If the relationship curves sharply, we won't be able to make this scatter plot straight. So if you see something that looks like this, where maybe it's almost looking like a parabola, this has a very sharp curve to it, we would definitely say that this is curved, but we won't be able to make that straight. Whenever you're talking about the form, I would recommend using words that end in ly. So you could say that things are roughly linear or generally linear. It's rare that things will be perfectly linear or curved, so we like to use these ly words when describing the form. The S in DFSU stands for strength. So at one extreme, if your points appear to follow a single stream and are tightly clustered together, regardless of whether they're straight, curved, or bending all over the place, this is considered strong. So here's a few examples of strong scatter plots. We could have something that's strongly linear, so a lot of dots here very tightly close together. This would be strong. We could also have something that's strongly curved, so maybe this way. Definitely not linear, but those points are still close together. On the other end, if you have points that appear as just a vague cloud, there's no trend, they're not close together, this would be considered weak. So a weak scatter plot would look something like this. There's no pattern, no rhyme or reason, the points are just all over. The U in DFSU stands for unusual. So we want to look for the unusual. Often the most interesting things to see in a scatter plot are the things we never thought to look for. So one example could be an outlier that's standing far away from your other points, something that deviates from that pattern. You also might want to talk about clusters or subgroups. If you see an outlier on your scatter plot and you're describing it, make sure you are specific and state where that outlier is located. Now, when we're making these scatter plots, we've talked about how there are two variables. Okay, these two variables play important roles. So it's important to determine which of these quantitative variables should go on the x-axis and which should go on the y-axis. We can make this determination by thinking about the roles that these variables play. So when the roles are clear, your explanatory variable goes on the x-axis and the response variable goes on the y-axis. Okay, just because we place a variable on the x-axis doesn't necessarily mean that it explains or predicts anything, and the y variable on the y-axis may not respond to it in any way, but by placing that on the x-axis, we call that the explanatory variable, meaning we think that it is doing the explaining. I'll give you a few examples here. Maybe I collected data on the amount of time that you spent studying for a test and your test score. Chances are I'm going to use the time spent studying to predict your test score. So I'm going to put time studying on the x-axis, use that as my explanatory variable, but then I would have your test score as the y variable. Sometimes you have two things that have absolutely nothing in common. So maybe I'm looking at GPA and gas mileage. I'm going to put miles per gallon. I'm going to guess that the miles per gallon your car gets and your GPA have nothing in common, so these two variables could be switched. Let's take a look at a couple more examples here. In these, we want to identify which variable we think should be the explanatory and which should be the response. So the first one says a statistics teacher compares the time his students spent studying, so that's one variable, and the student scores on that test. So this is the example I just gave you. My guess is we're going to use time spent studying as our explanatory variable and scores on that test as the response. The time spent studying should explain their test scores. Number 2 says a Boy Scout leader weighs the backpacks that the Scouts take on their camping trip and compares them with the weights of the Scouts. So we're comparing the weight of the backpack and the weight of the Scout. I think this one could be kind of interchangeable depending on what you want to do. Maybe we want to use the weight of the Scout to explain how heavy their backpack is. Maybe I believe that a heavier boy can carry a heavier backpack. You could switch these. In that case, you would be using the backpack weight to explain the weight of the Scout. Number 3, the legal limit for driving in all states is 0.08%. In a study, adult volunteers drank different numbers of cans of beer. 30 minutes later, a police officer measures their blood alcohol levels. So the two variables we're looking at are the numbers of cans of beer and their blood alcohol levels. My guess is that we are using the number of beers that this person drank to explain their blood alcohol level. And the last one, the National Student Loan Survey provides data on the amount of debt for recent college graduates, their current income, and how stressed they feel about college debt. A sociologist looks at the data with the goal of using amount of debt and income to explain the stress caused by college debt. Now this one, they're telling you what she wants to do the explaining. So my amount of debt and income has to be the explanatory. Stress levels will be the response. In our last example, I want to show you how to create a scatter plot on your calculator. We are not going to do this part here where we are editing the list, so you can ignore that. In this problem, we're looking at tuition costs at the University of Illinois, and we want to do two things. We want to create a scatter plot and then write a description. So the first thing that we're going to do in our calculator is type this data in. So let's go to Stat, Edit, pause this video to give yourself a minute to type in this data. Once you have the data typed in, we're going to edit our stat plot. This is where we make all of our graphs. So I'm going to second y equals, editing my first plot, and the scatter plot is the very first type of graph that you see. I know this last one could look like a scatter plot, but remember that is our normal probability plot. I have my data typed into L1 and L2, and I do want to use the year to predict the cost, so I'm going to keep those the same. And I'm going to press Zoom 9 to find my scatter plot. Now when you're drawing this scatter plot, you do not need to have scales on either axis, but you do want to make sure that they are labeled. So the x-axis was all this data I had typed into L1. This was the number of years after 2000. Keep in mind, I kind of skipped over this, but instead of using 1990 or 2000, 2010, sometimes they'll change these x values to just 0. This 0 is representing the year 2000. 1 is representing the year 2001, and so on, all the way until we get to the year 2010. The variable I had in the y, or my L2, that was tuition cost, so I'm going to put just tuition, maybe even include that that's in dollars. And here's where things are nice. They don't need us to be very perfect on this. We're just sketching what we see. So quickly sketch in kind of generally what you're noticing. Also make sure you have a title on your scatter plot. So I'm going to say U of I tuition. 3 things you always need with that scatter plot: title, labels, and then the general pattern. Okay, let's go ahead and take a minute to describe this scatter plot. Again, we are using that acronym DFSU, plus we want to always make sure we're talking in context of the problem. So I'm going to start with saying the scatter plot of, and here's where I'm going to list the 2 variables. So the scatter plot of number of years after 2000 and U of I tuition cost is, and now we'll go ahead and talk about direction, form, and strength just right in one sentence. So direction again looks at whether things are positive or negative. This is definitely moving upward, so I'm going to say that it is positive. Form is whether it's linear or curved. Although there does look to be a slight curve on this left-hand side, generally it's looking quite straight. So I'm going to say somewhat linear. You could say relatively linear here. Anything that's showing you know it's mostly moving in a straight line. And next I'll talk about S, which is strength. These dots are pretty close together. They're following just kind of that straight line pattern. So I'm going to say fairly or relatively strong. Again, if they were all spread out and kind of random, that's when it would be weak. The last part we want to talk about is any unique or outliers. I'm not seeing anything that deviates from that pattern, so I'm going to say no outliers are present. If we had a dot like way over here, that would definitely be an outlier. So I would say at the year 2009 or whatever the year is, tuition was much lower than we expected at however much tuition was. The last sentence, again, we want to put this back into context by saying as the number of years after 2000 increases, so that's always as your x variable increases. We're now going to look at our y variable, and it looks like that tuition is increasing as well.